Hello students, welcome to another tutorial on vectors. In this tutorial, we're going to look at the question I left you guys with last time. So let's look at exactly what we're supposed to do here. Now, when you look at this, if you go to the question, you realize that this question actually kind of tries to help you understand to say that it's not always about the sum when you're dealing with the resultant of two vectors. You really have to pay attention to what the question is saying. If they just say find the resultant of two vectors, then of course you're going to go on and evaluate the sum. But it is possible also to get the difference as a resultant. Now, in questions where you're supposed to get a difference, the question is going to specify to say that find the difference, or they're going to specify as they have in part 2 and also in part 3. But otherwise, if they don't specify that you're evaluating a difference and they just say find the resultant of vector A in vector B, then you go right ahead and perform the operation, the sum, getting the sum, of course. So you just want to look out for that. If they specify, you perform what they specify. If they do not, then you assume that they're talking about the sum. Okay, so let's go right ahead and see what we're supposed to do in this question. The question says, find the direction and magnitude of the vector sum A plus B in part 1. Now, where are the two vectors? Well, the diagram here gives us what the two vectors are. So if you look at this arrow, it's showing us the direction of the vector A, and the angle here is kind of specifying to say that this vector has two components. Of course, looking at the arrow and where it is going, you should see that the x component is supposed to be negative because it is pointing to the left, while the y component is going to be vertical, going upwards, implying that it's going to be positive. For vector b, on the other hand, you see that the x component will be going to the right, it's going to be positive. The y component will be going down, so we expect it to be negative. Now, let's get right ahead to our solutions. Well, the first part is the same as we were doing with the previous question. All you have to do is create a table. A table kind of simplifies everything that you have to do, because whether you're going to add or subtract, this table was to be magic, so to say. Okay, so let's see, how does it go? Well, for this table, all we have to do is identify the number of vectors you're dealing with. In this case, we're dealing with two vectors. So we're going to label those two vectors as, of course, they're labeled already for us, that's A and B. For each one, we want to see what the x component is and what the y component is. Now, in the first case, of course, we just want to look at the two vectors, getting their components. But what you should see is that in the first case, we want to get A plus B. This is for part 1. In part 2, we want to get A minus B. And then in part 3, it's going to be B minus A. Okay, so let's see, how do we do that? Now this table is just showing you the components. So if you want to look at A plus B, what I'm going to put here will be the x component of A plus B and the y component of A plus B. And down here, what I'll put here is going to be the x component of A minus B and the y component of A minus B. And then down here, what we're going to have is the x component of B minus A and the y component of B minus A. Now, let's go right ahead and find the components first of all. So if we look at our question, let's go back to our question. We look at our diagram. So we just want to create a picture of what is happening there. So let's try to sketch that. So we have our plane. So for our plane, we're being told that this is the vector A. And down here we have the vector B. The values that we're dealing with. For vector A, we see that we have the value is 30 meters. The angle it makes with the negative x-axis is 25. While for vector B, the angle it makes is 20 degrees. And the magnitude of the vector is 20 meters. Okay, so this is our x, and this is axis, our x-axis this side, and our y-axis vertical. Okay, so now that we have a diagram here, let's see how we get the components. Well, all we have to do is complete this so that we make a right angle triangle with the angle enclosed. So we see that we have the horizontal pointing to the left, so we expect that to be negative, and the vertical pointing upwards. So again, there's still two methods that we can use to get these components. We can use the other method where we measure the angle from the positive x. We saw that in some previous videos. Okay, so we can use that angle. So of course, to get this angle, all we have to do is subtract the 25 from 180, since when we add this plus this, we get 180, meaning that we get this, the bigger chunk. All we have to do is less the 25 from 180, we'll get the missing one. But of course, the method we're going to use here is just observing what is happening to the right angle triangle that we've made down here. Okay, so the x component. So here, this is ax. So of course, the relationship between the angle and the side, they're adjacent to each other. And because they're adjacent to each other, we know that we're going to use cos here. So the method that I always use here is that once you see that they are adjacent to each other, you're using cos, the component you're looking for is going to be the vector itself, 30, and then the ratio you determined, which is cos in this case. So the x component is going to be 30 cos the angle. The angle in this case is 25. Now, again, when you look at the direction of this component, it is going to the left. So don't forget to include a negative. That is one thing you have to keep in mind when using this approach. You have to, in the end, try to observe the direction of the vector. Is it going to the left? Is it going to the right? If it's to the left, it will be negative. To the right, it will be positive. Is it going up or is it going down? That is for the y component, of course. If it is going down, it is going to be negative. If it is going up, it will be positive. Okay, so for the y component, it's here. This is a in y. We see that a in y, this vector, it is opposite to our angle. So sine uses opposite. So we're going to use sine here. So to get this component, it is the vector itself sine the angle. So the vector itself is 30. Sine the angle is 25. So when you observe this component ay, it is pointing up, so it is going to be positive. So we leave it the way it is, positive. Now we come to the vector b. What is happening to our vector b? So to our vector b, we see that to make a right angle triangle here, we have the horizontal component and the vertical component with our angle enclosed inside. So this is the x component of b, the horizontal one will be the x component, and this is the y component of b. So again, here you notice that b, the x component, is adjacent to the angle. So because the x component is adjacent to the angle, we know we're going to use cos here. So of course, this is a shortcut that I always use, but of course, you can still go ahead and use the trig ratios to say cos will be something like this. So meaning it is cos the angle, that's cos 20 is equals to the adjacent, that is bx, over the hypotenuse, which is 20. But you see that this always simplifies to give you bx is equals to 20 cos 20. This is why I'm always saying, first just observe the side you want to find. It is adjacent to my angle, so I'm going to use cos. Once I identify the ratio I'm using, it is going to be the vector itself. The vector is 20, then cos the angle. You see that I still end up with this. Of course, we have already gone through these methods. If you haven't seen that yet, I'll leave a link to the introduction video where I went through that method at length. So of course, for the x component of b, that's the vector itself, 20 cos the angle 20 degrees. So again, when you observe b, bx is pointing to the right, so it is going to be positive. But by on the other hand is pointing down, so I know it is going to be negative. Now again, when I observe its relationship to the angle, the two are opposite to each other, and because they're opposite to each other, I'm using sine. So it's going to be the vector itself, 20 sine 20. So B is going to be the vector itself, 20 sine 20. Again, B is pointing down, so it's going to be negative. Okay, so with that done, the next part that we have to do is now to start evaluating our question, literally solving our question. Now, for the first part, we want to get A plus B. So all we have to do here, we can just add the respective components. This column here, it is showing the x components of B and A. So vectors will add according to their components. So all we're saying here is that to get this, first we can get the x component of the sum. So we get first the x component of the sum. I can get this resultant in x. Now say this is going to be A in x plus B in x. Now, if you look at what is happening here, I'm basically just adding these two, and they'll give me what comes down here. So what comes down here is the one I'm calling R in x. So it is just going to be A plus B in the x, or the x component of A plus B. I'll add the x component of A and the x component of B. What will I get there? Okay, so if I do that, notice that what I have in the first case, it is negative. That's 30. That was 30, yes. That's negative 30 cos 25 plus, then the other one is going to be 30. Sorry. This is the x component of B, so that is 20 cos 20. So if you perform the evaluation here, if you add these two, notice that what you're going to get here is going to be, if I write these to three significant figures, I'm going to get negative 8.40 meters. So of course, if I want, on my table, I can write, so okay, these components are going to have the unit of meter, and so this. So I don't have to repeat the units everywhere else. So this is coming out as negative 8.40. The next thing is, I'm now going to do the same for the y component. So again, I'm adding. So I'll add 30 sine 25 plus negative 20 sine 20. So I'll use the same method. You should see that this comes out as 5.84. Okay, now these are the components of A plus B, components of the sum of the two vectors. Now what we have to do is now to get the resultant of A plus B, the vector itself, or the magnitude of the sum. So to get the resultant of the vector A plus B, now we have to more like combine the two vectors. To combine them, we use Pythagoras theorem. Because what we have are the two pieces which make the vector. Now we have to combine the two vectors by Pythagoras. So what we have is negative 8.4 squared plus, that's 5.84 squared. So if you square this, you see that the magnitude of A plus B comes out as 10.2 meters. So this is the magnitude of A plus B. Now, the next thing that we have to do is to get the direction. Now, for us to get the direction, notice one thing. First, if you evaluate this directly, we're going to use tan for the direction. You'll see why. So we're going to use tan. And then for tan, what we're going to have is tan, the y component. The y component is 5.84 divided by the x component, negative 8.4. If we work out this, what we get is negative 34.8 degrees. Now, why do we use tan there? Because of one thing. If we tried to sketch, so some questions will specify that they want a graphical representation of the vector. Some questions will not. What I advise my students is to always show a graphical representation of the vector if they want the magnitude and direction, because that kind of also helps you determine whether the angle you're given is measured, in which direction it is measured. In this case, by looking at the components, the x component is negative, meaning that the x component is in this direction. The y component is positive, implying that this component is in this direction. So in other words, the vector a plus b is actually this one, going in that direction. This is the vector a plus b. So the angle that we have just found, this negative 34.8, is this angle here. We used tan. Notice that tan is equal to opposite of adjacent, and the opposite is the y component. The adjacent is the x component. That is why we use tan. Now here, what you see is that the angle you're given is measured in a clockwise direction. That is why it was negative. So otherwise, this is just 34.8 as an angle. The negative is just specifying that we measured it in the clockwise direction. The next thing that you want to look at is to present your answer, the angle, you have to measure it clockwise, not clockwise. You have to present it as anti-clockwise from the positive x. So we have to measure it from that side. So if I wrote this as phi, notice that what you should then see is to get, if you added 34.8 plus that angle phi, what you get is going to be 180, the angle of a straight line. This would then mean that the angle phi is given by 180 minus 34.8. This gives our angle, the one we're going to use, the direction, as 145 point, so we'll say 0.2 degrees. So when stating our answer now, we're going to say the magnitude of a plus b is 10.2 meters and the direction is 145.2 degrees from the positive x-axis, anti-clockwise of course. Okay, I hope that's okay. Now we're done with part one. We then look at part two. For part two, we're looking at the difference. So for the difference, we're now looking at, we want to find a minus b. So for a minus b, all we want to do is we come back to our table here. So instead of minus 30 cos 25, we're now going to say minus 30 cos 20. Instead of minus 30 cos 25 plus 20 cos 20. Now we're going to say minus 30 cos 25 minus 20 cos 20. Notice that it's the x component of A minus the x component of B. So how will it look like? So notice that it's basically what I was doing here, but where I was adding, now I am subtracting. So this would then mean that I have subtraction there and the subtraction here. So it's now ax minus bx. Let me just do it somewhere else instead of just raising that. Okay, so what I'm going to have is the x component of the difference is going to be minus 30 cos 25 minus 25. That's minus 20, sorry, cos 20. So you see that if you work this one out, what you're going to get here is going to be minus 46.0. This becomes the x component. Using the same method, you go to the y components. Again, for the y components, it's going to be the x component, the y component of A, which is 30 sine 25, minus the y component of B, which is minus 20 sine 20. And this is going to give us 19.5. So once we get the components, now we get there, so we can actually even get these components in fill them in our table. So for a minus b, the component comes out as minus 46.0, and then the y component comes out as 19.5. So from here, we can then combine the components to get the resultant. So a minus b will be equal to, again, we combine them by Pythagoras, so it's going to be minus 46. See that I'm putting in the brackets here because of that negative. So this is plus, and then this is 19.5 squared. If you evaluate this, you see that the answer you get is going to be 50.0 meters. That's the magnitude. The next thing after getting the magnitude of a minus b is to get the direction. So that's the magnitude of a minus b. For the directionals, again, we're going to use tan. So this is going to be tan inverse of the y component. So the y component is 19.5. The x component is 46. And this gives us, or this 46 is negative. So this gives us minus 27 degrees. Now, what you have to observe here again, when you try to picture or graphically represent these components, so you see that the x component is negative, so the x component is coming this side, negative 46. The y component is positive, going up 17. Again, you see that our vector, our resultant of a minus b is this one. So this is a minus b. So the angle we have found, that negative 27, it's this one here. That's 27 degrees. It's negative again because we're measuring it in the clockwise. Angle is supposed to be measured anti-clockwise. So to state it as a direction now, we have to measure it anti-clockwise from the positive x. So in the end, again, using the same method we used earlier on, should see that to get the direction we want, the direction of a minus b. So direction of a minus b will just be equal to 180 minus 27 degrees. So from here, you see that this is going to be this is not 27, sorry. This is 23. Yeah. So this is not 27, this is 23 degrees. Okay. So when you make the subtraction here, you see that this comes out as 157 degrees. So this becomes the direction of a minus b. Okay. Now, once you've got this, of course, this is the direction of a minus b. This is the magnitude of a minus b. The remaining one is now to find b minus a. So I'll leave b minus a for you guys to try out. Notice that you're literally still using these components here, but in the previous example, we're saying a minus b. For b minus a, you'll be saying b minus a. So I'll leave that for you guys to try out. Let's see the answers that you're going to find in the comment section. Okay, so that brings us to the end of this tutorial. In the next tutorial, we're going to look at another simple question. Now, we're going to look at this one. Now, when you look at this one, it's basically just preaching the same things that we're doing in the previous question. Finding the components of each vector. After finding the components of each vector, combining the components to get the components of the resultant. After doing that, using the components of the resultant to get the magnitude of the resultant. You would have been by part 3 already, and then using the components again, get the direction, and lastly, graphically represent the vector. The vector to show the displacement. So notice that this is a step-by-step approach to what we have been doing. So this is the question we'll look at in the next tutorial. Hope you guys found this helpful. If you did, leave a like, and if you haven't subscribed yet, you can join us now. All right, we'll see you guys in the next tutorial. This was your tutor.